Okay, homework 6, problem 1. So here we are given a joint density function. And part A, we are asked to find the constant b such that it is a valid joint density function. So first let's try to draw this condition. So this condition is that 0, x less than y is in between 1 and 0. So we can look at this piece as x less than or equal to y, which is the same thing as y is less than or is greater than or equal to x, which is just whatever is above the line y equals x, which I did dashed here in pencil. However, we have to be careful because it's whatever is above this line but within the region 0 and 1. So y is in between 0 and 1 and x is in between 0 and 1. So we only care about this piece, right? Because it's greater than, so we care about the above piece, and it's in between the intervals 0 and 1 for both x and y. So that's what this looks like. So now, in order for this to be a valid joint density function, the integral of the joint density function over where all space has to be 1. So we have b xy. So by all space, all we care about is this shaded region. So I'm going to integrate first with respect to y. So y is going to go from x to 1, right? Because this line y is equal to x and goes to 1. So we go from x to 1 dy. Then dx is going to go from 0 to 1. And this has to be equal to 1. So the first integral is going to, so let's write. So we're going to get the integral from 0 to 1 of bx. The integral of y is going to be y squared over 2, so we're going to get 1 over 2 minus x squared over 2 dx. This is supposed to be equal to 1. So we can take the 1/2 and the b common factor out. So now we're going to have an integral of x minus x x minus x cubed, right, because x comes in here, dx from 0 to 1. So now we're going to get, and this has to be equal to 1, we're going to get, this is going to be x squared over 2, evaluated from 0 to 1. So we're going to get, first we have the constant here. This guy is going to give me 1/2 minus, this guy is going to be, the integral is going to be x to the 4th over 4, evaluated from 0 to 1, so it's just going to give me 1/4. And this is supposed to be equal to 1. So 1/2 plus 1/4. So 1/2 is the same thing as 2 over 4. 2 over 4 minus 1 over 4 is 1 over 4. So this is going to be b over 2 times 1 over 4, which is equal to 1. 1 over 4 times 1/2 is 1/8. So it's going to be, running out of space here. This is going to go over here. So we're going to get b times 1 over 8, which equals 1. And then b is just equal to 8. So that's the first part. That's part A. Okay. Get this page. Okay. So now, I want to look at part B. 1 second. Making a correction in my notes. So part B asks us, find and sketch the marginal density functions, f of x and f of y. So what's f of x? F of x is just going to be f of xy, but we're going to integrate y out. So this is just going to be, well, what's our joint density function? It's going to be 8 times xy dy Now, where does y go from? The only place that y goes from is from x to 1. So, let's do that. We get 8x. Y is going to be y squared over 2, evaluated from x to 1. So we're going to have 1/2 minus x squared over 2. So, these 2's cancel with this guy to make a 4. So this is going to become 4x multiplying through minus 4x cubed. And remember, this is 4x in between 0 and 1. So part B also asks us to sketch what this looks like. So let me get my ruler. So this is going to look something like this. It's going to go up like this. I'm expanding it. So this point up here, that's going to correspond to the peak, and its peak is going to happen at 1.5. And it's going to end here at 1 because it only exists for here. So this is what little f of x looks like, and its function is up here. Okay, now we want f of y. This is going to be the integral from negative infinity to infinity of f of x y with respect to x, because we want to integrate x out. So this is going to be, we have our density function 8xy dx. Where does x exist? X exists from 0 to y. So this is going to become, we can take 8y out. We have x is going to be x squared over 2, so we're going to have y squared over 2. The 0 goes away. Y squared over 2. And this is just going to become, let me do this. The 2 cancels with the 8 to make a 4, so I get 4 y cubed. Now I'm going to just write it again. This is 4 y in between 0 and 1. Now what does this look like? Let's draw it. So we have a point here. So this is going to be 1/2. This is going to be 1. This is going to correspond to 4, because at 1, f of y equals 4. At 1/2, we get here. So we have at 1/2, right? So it's going to look something like this. So at 1, we plug in 1, we get 4. At 1/2, 1/2 to the 3rd power is 1/8. So 4 times 1/8 is 1/2. So this becomes 1/2 here. Okay. Right. 4 times 1/8 is 1/2. Okay. So that is part B. This is our marginal density function for y. So now let's move on to part C. Part C asks us to prove or disprove that x and y are independent. So in order to be independent, this condition must hold. So let's check that this condition holds. F of xy is just going to be 8xy. f of x we found to be 4x minus 4x cubed times f of y was 4y cubed. So this question mark is just we're just checking it. 8xy. This is going to be 16xy cubed minus 16x cubed y cubed, and clearly this does not equal that, so x and y are not independent. And that completes part C.